Hello, let's continue our Sudoku adventure with Average Sudoku by Clover. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have average lines in here, also called mean lines. It's a mean kind of average, as opposed to median or mode or geometric or harmonic. Anyway, the way these work is they're basically always completely in one cell. They're completely in one cell and they barely touch two other cells. And so the digit in the middle is the average, the mean of the other two. So let's just say this was a 5. What we would do is we do 1 plus 5 is 6. We divide that by 2 to get 3, and the 3 goes there. So this is one way this line could get filled. That's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so we can't let our means be half, right? We can't do like 2.5 or 3.5 as our mean because it needs to be a digit. So that means that the sum of every end of our of these lines, that the sum of each end needs to be an even number, so we can divide it by 2. So I'm going to mark this orange as odd and then this blue as even. And I'm going to say, well, we need to match that on the other end. So if this is odd, this has to also be odd because odd plus odd is even. Odd plus even would be odd. And so we have odd on both ends. And then here we need even on both ends. And they're not 2s. So this is 4, 6, and these aren't 1s, so these are 3, 5. Now, if it was 1 plus 3, that would be 4. That would put a 2 here. If it's 1 plus 5, that would be 6. That would put a 3 here. So that's 2 and 3. That's 2 and 3. This also goes to an even. 2 plus 4 would be 6. That would be 3. Oops, that would be 3. 2 plus 6 is 8. That would be a 4. So this is 3, 4, and this is 3, 4. Okay. Now this is 2, 4, or 6. So let's see here. If this could be anywhere from 6, 8, or 10. So this is 3, 4, or 5. Okay. It's also 3, 4, 5. So this is what I've got. Did I make any pairs, or is there some other deduction I need? Is there a problem with something like 2, 3, 4 or 2, 4, 6? Not that I can tell. What about like 4, 5, 6? There's some interaction here. Like if this was 2, 3, that uses up the 2, 3. So this would have to be a 4, 6 pair. That would make that 5. So one of these is always 5, I guess. Let me explain why. So if this was a 3, this would be 2, 3. So let me just corner mark that so you can see what I'm visualizing in my head. So that would be 2, 3. So now we wouldn't have 2, 3 available here anymore. So that would force this to be a 4, 6 pair, which adds to 10, and that would put a 5 here. So if this is the 2, 3, then the 5 goes there. Otherwise, it's the 3, 5, and the 5 goes here. So one of these two must be 5. And I wonder if we have more stuff like that we can do. It does put a 5 in one of these two. See, we don't know that these are pairs. They could be the same digit as each other. Same thing here. What if this was 3, 5? Okay, if this is 3, 5, this would be a 4. So this is never a 3. Yeah, there's always a 3 involved in this sum here. One of these must be 3, because we're either doing 2, 3, or 3, 5. And so this is not a 3, which means we can't add 2, 6. So this can never be a 2. Oh, no, it can be a 2. It would have to be 2, 6, though. Yeah, okay, that actually works. We could do 3, 5, 2, 4, 6. Is one of these always a 4? No, I could do 6, 5, 4 here. One of these is always a 4. One of these is always a 3. How about over here? One of these is always a 4. We're either doing 2, 3, 4 or 2, 4, 6. So one of these two is a 4. One of these two is a 4. Okay, so 4 is one of these two. That's not a 4, which means it's odd. Oh, 3-5 pair makes that a 4. Okay, now we're doing well. Okay, that's even. That's not a 6. And so what does that do for me? 4 is always in one of these two, right? We either do 2, 6, which has to 8, putting a 4 here, or 4, 6, in which case that's a 4. So 4 is in one of these two. What are we doing here? 3, 4, 5 triple. Where do the 1, 2, 6 go? They go here. I don't know how much more I need to be coloring, but 3, 5. I'm thinking about whether these two are the same digit as each other, because if they were, it would also go here. It would be the only place in this box to put it. And then it would go here. And then it would go here. And then it would go here. So if these are the same as each other, they go in these spots exactly. If they're different than each other, then these are also different, and it forces this to be 4, 5. So these would be a 3. Huh. Or it would be, sorry, this would be a 2, 3 pair. This would be 4, 5. And so this would be 3. Sorry, 2, 3 pair would force this to be 4, this to be 5. This would be 3, 2. Yeah, I mean, it doesn't seem to be problematic either way. I'm obviously missing something important. I have this 3, 5 pair, so I'm going to put 1, 2, 6 here as well. This isn't a 2. 1, 2, 6, 2, 3. Is there something about this interacting with this? This always has, what does this always have? It's either going to be 2, 3, 4, or 2, or 4, 5, 6. Yeah, this can't have a 4 in the middle. So we can't add to 8. We have to add to 6 or 10. So we're either 2, 4 or 4, 6. So yeah, this always has the 4 in it. What do I do with that? Let's see, if this was a 2, this would be 4, 5, 6. Interesting. So that makes these two the same. No. It makes these two the same. Huh. If this was a 2, we'd go 2. What was I saying? Wait. I'm confusing myself. There's something weird here. Let me go through it slowly. If this was a 2, then we have to add to either 6. We can't add to 8, so we'd have to do 2, 4. So this would be 2, 3, 4. Okay, I thought this contradicted, but I don't think it does. If this is a 2, we go 2, 3, 4. Oh, no, that doesn't work because of this 2, 3. So if this was a 2, this would be 3. This would have to be 5, and we'd have to do 2 plus 8, which doesn't work. Okay, so let me make sure I'm clear. I'll just write it out for you. If this was a 2, then it forces this to be a 3, just by Sudoku. And now this is forced to be 5, but now these two have to add to 10, which we can't do with a 2. So the conclusion is it's not a 2. This has to be 4. It makes this 6, this 5, this 3. This has to be 2 to be the average. I'm going to get rid of my colors at this point. That makes this a 5. That makes this 3, which makes that a 2. Okay, so these are the same. So remember, we could trace where they go. They go here, and here, and here, and here. Okay, so they're done. So these are not 6s, which places the 6 in the row. This is a 4. I think all our lines are working. 1, 2, 3, 1, 2, 3. 4, 5, 6, 4, 5, 6, 2, 4, 6, 2, 4, 6. Okay. 1 for the column, that's 6. This is just a 1 for the box or the row. Take your pick. I think we're just doing Sudoku at this point. I think we have, I mean, that's all there is left. We need a 1 in this column, which goes there. So that's 2. That's 1 and 2. This is a 5. Over here we need something, 4 and 6. Then over here we do need a 1, which goes there. This is a 5. Over here we need not a 3. We need a 5. Down here we need 2 and 4, so that's 4 and 2. Here this is not a 6, so that's 4, that's 6, that's 4. And then up here we need the 5 and 6, and we're done. All right, cool puzzle, Clover. Yeah, I had to think about, see, the key step was thinking, was this 2, 3, preventing this from being 2, 3, 4. Very interesting. And then we eliminated the 4 from here, so we couldn't do a 2 here at all. Very cool. Let me know how you did, and if you enjoyed this, why not leave a like, subscribe, and a kind comment below.